High Voltage takes center stage in this season of Hitachi Energy's Power Pulse podcast. We promise to bring you great content from the brightest minds in the business. We'll discuss challenges, opportunities, and all the hot topics any high voltage enthusiast, or anyone interested in sustainability for that matter, is sure to enjoy. This episode of the podcast is dedicated to all design engineers interested in the nitty-gritty of Hitachi Energy's eco-efficient portfolio, EconiQ. To answer all their questions, we invited Amaya Lago along. Amaya is a territory manager in the European region. She holds a master's in industrial engineering and an MBA, and has been in the industry for over 2 decades. Amaya will tell all design engineers exactly why the claim we make that we have the one solution with zero SF₆ and the lowest carbon footprint is absolutely true and backed by tried and tested science. So all design engineers on the fence, do tune in. Before we get stuck in though, we should add that all non-design engineers will also most definitely find this episode interesting. We'll make sure to keep it jargon-free and accessible to all. Enjoy.
Welcome back to Power Pulse. I'm your host, Sam Dash, and today I'm speaking with Amaya Lago, Hub Product Marketing Manager for the European region. Hi, Amaya.
Hello.
So, Amaya, can you talk to me a little bit about your trajectory into high voltage? I saw that you have a fascination with neuroscience, and that's quite personal to you. Can you tell us a little bit more about that?
Sure. I have 3 boys, and one of them has dyslexia. We found out that he was struggling somehow when he was 4 years old. And in that moment, I decided to learn how the brain learns in order to help him to learn, because not all functions were properly working in his brain. So to try to have tools to help him learn what he needed in a different way. And then learning about the brain became my hobby. Also, my father is a doctor. So whenever it was too technical for me, I would share it with him. So it became our hobby.
Yeah.
And everybody has a brain. So I find it very useful for my everyday job.
Yeah, there's something interesting about that. You have also decided to work in an industry where everyone uses energy, and you're working in that field to understand how we use that energy and how you can better understand the needs of the people using it.
That's right. And also, some people have the perception that engineering is like very structured and like kind of boring job. I think engineering is a very creative job. I have met many colleagues that also have dyslexia, and they see the reality in a different way. So they help us to find different solutions that very often are better than the ones that people that don't have this problem might reach, because we go through shortcuts. They have different tools to do the same things. So I have had wonderful experiences with some colleagues that I told them, how did you see that? No, and they told me, no, I'm dyslexic. So I had to search this way. And then they perceived the things that we were not paying attention to.
Right. That's a skill set that I feel like is quite valuable in multiple arenas with your family, for example, but then also in a work environment where you're really looking for solutions that are outside the box. Is that right?
Yeah. Yes, absolutely.
So I've also heard that you're very passionate about sustainability, and I'd love for you to tell me and our listeners more about that and what innovations you see as game changers currently.
Well, I believe that sustainability is part of our responsibility. I believe that we need to take care of the future, especially talking about my kids. I want to be sure I'm doing my best to ensure a good future for the new generations. So it's a must for us, and it's a priority. Now, we are in the electric industry. We are going through a very, very strong change. Talking to our customers, we say that we see a change that we haven't seen probably in 100 years. So it's a major game changer right now. And I'm very, very passionate about, of course, our solution, the solution that Hitachi Energy developed, and we keep on developing to serve the purpose we have for high voltage products.
And what is that game changer?
Basically, until now, we have spent over 40 years developing products that use a gas that is very contaminant, has a very high global warming potential.
And that's SF₆, is that right?
Yes, correct. It has amazing characteristics technically, but it has a very, very strong impact in the environment, and it's simply not acceptable to keep on using it. So we know the technical characteristics we need, so we investigate it strongly. There was a creative process in between, and our talented R&D engineers managed to find a solution that basically fits 2 purposes. On one hand, it fulfills all technical requirements that we need from the high voltage switchgear. And on the other hand, it is the best solution from a sustainable perspective. Because whenever we design any high voltage product, we need to think, what is the purpose of the product? That cannot be forgotten. So it has to fulfill all the technical requirements while also fulfilling the sustainability requirements.
That makes me think, you just said a little while ago that this is a pivotal time in the industry that hasn't existed in over 100 years. For those of us who are unfamiliar or less familiar with the history of energy and the industry, can you tell us a bit about what that history is and what that pivotal moment was 100 years ago or so?
We were using many different technologies in the past.
Yeah.
Including small volume of oil. We were using vacuum technology. We were using many different technologies until the SF₆ technology appeared, when we were able to control properly the SF₆ as an insulating gas. Then we used it massively. All manufacturers used it, and we have been using it for over 50 years. Slowly and steadily, it was substituted by different technologies from the low voltage to the medium voltage, and the last products to be substituted were in high voltage. We started quite early. In fact, Hitachi Energy commissioned the first breaker without SF₆, with the technology we are using today, in year 2010.
Okay.
So by now, we already have a very good experience at site, not only in the laboratory, because I always say that nature can surprise you.
Nature can surprise you, yeah.
So in the lab, we test everything possible, but sure, nature will show that we didn't test enough. So we have already quite a valuable experience at site with this technology that we call EconiQ. And honestly, we learned a lot together with our customers.
Yeah.
And we are still developing a lot of the portfolio because, as I explained, in order to have the portfolio we have today with SF₆, it took us 40 years. So we are still developing the portfolio with the new technology, but there are amazing times coming.
Yeah, and it takes time to get there.
Yes, of course, because for us, it's not only the fact that you launch a product that has a good performance. The product has to be reliable, and it has to be able to work even in the most challenging conditions.
Right. Right. You mentioned earlier a bit about engineers, and I wonder if we can go back to some basics. Can you explain what a design engineer at a typical utility company does?
Yes, of course. It's a hard job, I have to tell you. The design engineer has to take into account the needs of the engineering department, which are the ones that are doing the drawings and planning how everything will be in the substation. The construction department, which is the one that really builds the substation and typically has different needs from the product. And then the maintenance department, which is the one that basically operates the product and maintains the product until the end of life. And typically they also take care of removing the product and making sure that it is recycled at the end of life. So typically the needs sometimes have conflicts. For example, typically the engineering department will require the product to be very compact because typically the land is limited. The space is limited.
Yeah.
But the maintenance department would like to have access everywhere to the product in order to do maintenance. And in order to have access, you cannot make it too compact. So there are different interests from the different stakeholders in a utility, and the design engineers have to come up with a balance, let's say a solution that will fit all the needs of the utility. And they write down a specification in order to make sure that what the company is using and procuring fulfills what they need. Also, they need to know what the network requires, the electrical network. The network is not the same in every country, and even it's not behaving the same in every region. It will depend on how many power plants there are or how many industries there are. It varies, and they need to have very good information on their network.
Yeah, so it seems like design engineers are balancing quite a lot of different components, mediating the needs of a lot of different stakeholders and forces. Is that right?
Yes. They need a very broad knowledge on the needs of the utility and also the products available in the market.
So when you visit a design engineer, I assume you talk with design engineers on a daily basis.
Yes, on a daily basis.
Yeah. When you talk with them, what questions are you asked most, and what are your answers that you give them?
Yeah, when I talk to design engineers in general, The first thing I do is listen to them.
Yeah.
Because I always say that we know how to manufacture products, but they know how to use them better than us, because actually we manufacture them, we ship them, we commission them, but then they use them.
They have the experience on the ground with those products.
Yes. So all the feedback they provide us, for us, is gold. And one of the targets of my job is to tell our R&D colleagues what our customers need for the future, because also the networks evolve over time. So the first thing I do is to ask them what do they need, etc. The questions I get related to this technology, to EconiQ, is, for example, if I'm sure that our life cycle assessment is the smallest one. So the life cycle assessment is the tool that we use to measure the impact in the environment of the full process to produce a product. So it includes the production, the transportation to site, the use of the product, and then recycle it at the end of life. So it's a tool we use to measure the impact, what we call the carbon footprint, the impact on the environment. And typically they ask if I'm sure that the EconiQ portfolio has the lowest life cycle assessment. And of course, I'm sure. I typically explain them the main contributors to this impact of the environment, to the life cycle, are the material, and when we are not considering SF₆, and our product has the best performance in this field. And not only that, our product is the most compact product. So as it is more compact, it uses less material, but also it will require a smaller building. And then the civil works will be smaller. And civil works also have a very strong impact in the environment. As a general solution, it's quite compact, it is scalable, and it has the lowest carbon footprint.
And when you say scalable, can you say more about that, what that means?
Yes. The solution that we found can be used from 72.5 kilovolts, which is the lowest voltage that we consider in high voltage, up with no limit. Right now, we have available products that are in the market up to 420 kV, and there is more coming.
Yeah. Amaya, how do you make sure that your equipment complies with regulations?
Well, basically right now, most governments are concerned about sustainability, and they are putting limits in the use of F-gases. So let's say the technology we have been using until now was using SF₆, which we know is a gas that has a very strong impact in the environment. And the new equipment that we are proposing to be used contains, for the lifetime breakers, only CO2, O2. So we use 90% of CO2 and 10% of O2, which is oxygen. And for the metal enclosed switchgear, we add on top an F-gas that is called C4FN. And we only use 3.5% of the gas mixture of this C4FN. The rest is CO2 and O2. Now, C4FN is a gas that has a substantially lower impact in the environment. So the GWP equivalent of the gas mixture is a little bit under 400. And the C4FN is a gas that is classified as non-toxic. And also it decomposes in nature in presence of daylight in about 30 years. So basically the impact in the environment because of any losses that we might have of the gas mixture is negligible, while we can make the equipment substantially smaller, much compact. So we use less material, and because of that, the impact in the environment is substantially lower as a whole. So when we look on the full life cycle of the product, so the impact in the environment to extract the raw materials, to manufacture the product, to transport it to site, to use it, and then to remove it at end of life and recycle it, the full life cycle CO2 equivalent is substantially lower, even if we use C4FN in the gas mixture, just because we are able to do the product smaller and more compact. And not only that, many of our products, well, all of our products require civil works, but many of them are inside buildings. So the civil works are even more important to be done in the substations. And the impact on the environment of the civil works are also very relevant. So if you need bigger buildings, the impact in the environment is going to be bigger. So in general, the way we fulfill the regulations is through two ways. On one hand, our performance related to sustainability or the life cycle CO2 equivalent is substantially lower than other solutions available in the market. And also, technically, we fulfill the technical specifications, which is the main purpose for the high voltage equipment in the substations.
And Just to go back a moment, when you say that gas in EconiQ decomposes naturally and takes 30 years, right?
Yes.
And you said that the effect of that is negligible. For those of us outside of the industry, what does that mean when something is negligible?
For example, if we take as an example Norway, and if we install a gas-insulated switchgear in that country where we say the energy mix is CO2 neutral because they have a lot of green energy, then if we look at the impact in the environment of an SF₆ switchgear, the majority of the contribution to the impact of the environment is the leakages of SF₆, because SF₆ has a very high global warming potential. But when we look at the impact of the environment, if we use the new gas mixture, the CO2, O2, and 3.5% of C4FN, the impact in the environment is so small compared to the materials. Let's say we can't forget about it. The materials, in that case, are about 80% of all the impact of all the industrial process, as I explained previously.
So it's quite small by comparison to the previous infrastructure that was being relied on.
Exactly. Because of the change of the gas mixture that we are using, it's a game changer again. The way we evaluate the impact in the environment is totally different. In the past, we were fully focused on minimizing the leakages and how to control the SF₆s we had inside the compartments. For example, typically we use density monitors to ensure that there is no leakage. We are permanently monitoring the gas we have. In the new substations, we also have density monitors for other reasons. Basically, if we lose the gas, the equipment will not work properly, so we need to know. But the impact in the environment is so small compared to the impact of the materials that we don't even take it into account.
Interesting. Now, I've seen that the EU, for example, the European Union, has passed a law this year which focuses on the phasing out of F gases in the high voltage energy sector. Does this law include all F gases?
This law is regulating many F gases, a very relevant amount. I'm not sure if it contains all F gases because there is a lot of annexes in the regulation, but surely I would say that it limits, if not all, most of those that are being used, not only in the electrical industry. It is a regulation for all industries in the European Union.
Oh, interesting. And so the EconiQ gas mixture, which does contain an F gas, fluorine gas, where does this fall in the new regulation?
Not all our portfolio uses the F gas. In the lifetime breakers, we only use CO2O2, so our base gas mixture is always CO2O2.
Okay.
In the lifetime breakers, we don't need to add anything else. And then we use 90% CO2 and 10% O2. Wherever we have a metal enclosure, we add 3.5% of this F-gas that has a substantially lower GWP in order to make the product more compact.
So it has a much lower global warming potential than lots of other F gases, is that right?
Yes. For example, SF₆ has a global warming potential of 24,300, while the gas mixture that we use, when we use 3.5% of this F-gas, it has a GWP slightly lower than 400, which is a very relevant change, no? And what the number means is that 1 kilo of the gas mixture or 1 kilo of SF₆ is equivalent to 24,300 kilos of CO2, or 1 kilo of the gas mixture is equivalent to almost 400 kilos of CO2.
Right.
So it's quite an improvement.
Yeah.
And that's why whenever we are using the new gas mixture, even if there are leakages to the atmosphere, the impact that it has is basically negligible. Mm-hmm. But it allows us to use much less material. So all the impact in the environment, because we use less material, is basically saved because we are using this gas mixture for metal enclosed switchgear. And that's a relevant change in the results. And not only that, because we are using gas breakers, we have better technical performance when it relates to all the purpose that the high voltage equipment has to fulfill in the substation.
So Amaya, talk to us about the technical specifications and requirements that the customers have. Are those particular for use with a certain kind of technology?
The technical specification is the basis. So what design engineers do, which is basically the technical specifications for us, for the manufacturers, is the basis for discussion. We cannot talk about sustainability if we are not sure that the electrical networks are safely used. The electricity is the backbone energy of today's world. It is the most sustainable way to transport energy, but we need to ensure that it is safe and reliable. And in order to be sure about it, we need to be sure that the technical requirements that the customers have are fulfilled. This is the basis and cannot be discussed. That is why our solution is the best one that the customers can choose.
When you say it can't be discussed, do you mean like it's non-negotiable?
In general, it is not. Of course, in every technical specification, you will find requirements that are must-have and others that are nice to have.
Right.
So, of course, we can make comments and we can do questions. But for the main technical characteristics, and also sometimes the size, for example, if there is no more land available, there is no more land.
Mm-hmm.
So the technical specifications include a lot of information. The temperature, for example. In Europe, which is the market I take care of, we have regions that are even minus 60 degrees, and we have to fulfill. Or whenever we use some equipment that is indoor, it has to be indoor, and we need to make sure that it will work properly indoor or outdoor. So there are some technical characteristics of all kinds, not only electrical characteristics, that have to be fulfilled in order to ensure that the substation will function properly.
Now, I'm told that Hitachi Energy made EconiQ possible with the help of design engineers who helped achieve milestones like the 420 kV dead tank breaker. How does the EconiQ portfolio differ from other solutions in your mind?
Well, the EconiQ portfolio has not only the technical reliability, but also the compactness and scalability. The scalability means that we use the same gas mixture, the same solution for lower voltages and for very high voltages. So today, Hitachi Energy produces even breakers, circuit breakers, dead tank breakers, as you mentioned, and also gas-insulated switchgear up to 420 kV, which is a very high voltage level. In Europe, it is what we call the transmission level. And of course, we also produce it for lower voltage levels, for 145, for example, 145 kV. So we use the same technology all through the portfolio, which is a very important advantage for customers because they have to be trained only on one technology.
Mm-hmm.
Whenever they use it, they can use it safely because they know the technology independent of the voltage level of that specific substation. For the maintenance people, all the tools they have are common for all the portfolio. So it's a very important advantage. Also, taking into account the safety of the people that are using the products.
So you've touched on this a little bit earlier, and we've had some other guests talk about this as well. But what do you see as the future for the EconiQ portfolio, and what is your involvement in that journey?
Well, as I explained, one of my jobs is to listen to the customers and understand what they need, and then come home and explain our talented R&D engineers what we need in 5 years, not what we need now,
right?
What we need in the coming years and what we need to develop and the challenges we will face.
Because you need to be one step ahead, really.
Absolutely. Yeah. For example, with all the renewable energy that is being installed, the requirements for the networks are changing. And we, talking to our customers, they can share with us what they expect to find in the future. So we need to work now for the products we need in a few years. It takes long to develop a high voltage product.
Yeah, right.
So that's part of my job.
Can you give us an example of something one of your clients has said to you recently that speaks to this, that speaks to looking ahead, we will need this or we want this for our system?
Yes, it's very technical, but with a higher amount of renewable energy being installed in the network, we find that we need higher short circuit currents.
Higher short circuit currents, okay.
Because whenever there is a short circuit, if there is more generation, we are providing more current to the short circuit and it is increasing. So because we have more renewable generation around, that current is increasing. And we have to be ready to open that current with our breakers.
For those of us, again, who are sort of outside the industry, what does that look like, opening the current?
Well, last month, I went to a university in Madrid to talk to the students to explain them everything that happens in a circuit breaker in order to open the current.
Yeah.
And when I finished, they thought it was like a miracle. Many things have to happen inside a breaker to make sure that we interrupt the current. And this is key for the safety of the network and for the people also.
Yeah.
So it's a long technical process, but basically you can imagine that if the current increases, it becomes more challenging to open that current in general. So with higher short circuit currents, a short circuit by itself has a very, very high current. So opening this current can be challenging. And we need to make sure that we develop products that will be ready, available by the time that current is higher than the actual one.
Do you see certain clients approaching that time more quickly than others? Or is everyone around the world really on the same track to approach that time simultaneously?
The world is very different in general.
Yeah.
Even in Europe, not all regions are the same. But it can happen that you learn from a customer. We have the case that customers use our product in a different way than we thought. Mm-hmm. And it's actually safe, it's working, and sometimes a solution that a customer explained to me with our own products, suddenly another customer from a different country explains me their problem, and I tell them, well, look, your colleagues from this country solved this way with this product of our portfolio. So these things also happen because, as I explained before, the creativity of humans has no limit.
Yeah, I mean, you're circling back to sort of where we began in a beautiful way, which is that there are other ways of looking at a problem, other solutions that you may not see from your angle, that someone else can see from theirs. And it's helpful to step into their shoes and see what they're seeing so you can be better informed about the different possibilities at your fingertips.
Yes, absolutely. It's a privilege, at least for me, to be able to see how our products perform and also to collect the feedback. What do we have to improve? And related to EconiQ portfolio, we will see exciting things coming. So very shortly, we are going to release the lifetime breaker in 420 kV. And we will also see coming the new gas-insulated switchgear in 550 kV, which is a very high voltage. And also the time breaker in 550 kV. And we also have a solution that we call retrofill. So whenever we have a very long duct, like a very long tube filled in with SF₆, we can remove the SF₆ and use a different gas mixture, basically the new gas mixture we are using with some changes. So we actually reduce the carbon footprint of already existing installations. Mm-hmm. And that is also coming up to 550 kV.
Terrific. So it sounds like we have a lot to look forward to.
Absolutely. And also we will have, after that, we will have hybrids in 145 kV and 72 kV. The hybrid is an equipment between the air-insulated switchgear and the gas-insulated switchgear. And even actually now with SF₆, we have the most compact design. And we are very, very excited to have it in EconiQ very soon.
Thanks so much for joining us today, Amaya. It's been a privilege. You've expanded our understanding of EconiQ and what someone like a design engineer contributes to the process of making more sustainable solutions for high voltage. Thanks for tuning in to this episode of Power Pulse. Until next time.
Thank you.
And that's it for today. We'll be back soon with some more great content. But before you go, remember to give us a follow so you don't miss an episode. Thanks for tuning in. See you soon. This episode was brought to you by Hitachi Energy. Created and introduced by Barbara Freitas-Daniels. Content and script writing by Cassandra Inay. Guest speaker, Amaya Lago. Hosted by Sam Dash, produced and edited by Creative Chimps.